Hi, this is Jeff from the Ozark Mountains in Missouri, USA. You might be wondering what this little thing is. Well, it's one of these. There we go. It's an HP 3476A multimeter. It has a bubble LED display. It's auto ranging. The leads plug into the side. This thing came out about 1977. Pretty unique device for that time. Very small, rather funky styling. And I bought a couple of these from University Surplus years ago. They've been sitting on the shelf. I've been cleaning up recently. And now I am dying to plug these in to see if they work or see if we can fix them. Let's get started. Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. And this is PCBWay's 9th anniversary, and they're having lots of promotions, coupons, sales, etc. So go on over to PCBWay and check them out. Okay, first we'll do a bit of a tour. As I mentioned, it's an HP 3476A digital multimeter. It is auto ranging. It has auto and hold. You can stick on a range. Over on this side is where your leads connect, and you can slide this panel out of the way and you can just see the fuses right in there. And I'm not going to slide that all the way open because it's a pain to close, because you got to kind of hold your mouth just right and press the fuses down and slide the panel and pat your tummy and rub your head or something all at the same time. And the back is kind of boring, but we can see it was used in room 203. AC input. These also did have a battery option, I think. 6 volts. 6 volt amps, 60 milliamps. That makes more sense. Wide AC input voltage range, basically 104 to 127, 54 to 66 hertz. Unfortunately, these have these inventory stickers on here, and these type of stickers are pretty much impossible to get off without destroying things. That was the point of them. The solvent on there, you'd use a solvent called Fedron to soften the adhesive and stick it on there, and it's pretty much permanent. It has this little bail, which is kind of interesting. You can do this to have it flat down like that. You can go like that for pinch use. You can even go like that, so you can look at it standing up. Let me lift up the camera here, like that. Pretty interesting. So I think we'll use this orientation, and you notice that if I can tip this up here, these buttons have this kind of weird S shape on it, and the others do not. These are a latching button that aren't connected to anything else, and these are mode buttons, so they pop each other out, or if you hold your mouth just right, you can get it to select no mode. And of course, power is also a latching button. Okay, now I don't know when this thing was last powered up. I've had it 6 or 7 years and I have not powered it up, so we'll see what happens here. Plug it in to the mains and place your bets, and if it's going to light up. Oh, I see dashes. And nothing. What about nothing? Nothing. So there is some life, but nothing. I don't suspect we'll have to have leads plugged in, but just in case, no. And I think even if our fuses were blown, we would have something there. Okay, let's try unit number 2. See what it does or does not do. Power on. Oh, this one lights up. But it looks like we're missing the tops of all the segments. So it's UUU1. It must be that Klingon numbering system. So let's do this. And it's in volt mode, so if I short it out, we got 0. Ooh, that looks really promising, doesn't it? And ohms mode, 0. Excellent. Let me get a resistor to measure. So you can see, oh, the dash is like an open circuit type of thing. Oh, so maybe the other one is just... What about in volt mode? No, it should measure something in volt mode. Okay. But the open circuit indicator for ohms mode is dashes. Random resistor here. This might be 100K. I can't quite see it without my old man glasses. And it's reading about 100K. Sweet. I don't know why that's reading 120 now. I'm not sure what this... I have to read the directions to see what that auto hold does. What happens if we press it now? Okay. So it must hold the range that it's currently on. So if this was on a way different range than what was ideal for this 100K resistor, then we might not get as accurate a reading. That's what I'm guessing. Okay, so other than... Oh, look, we got the tops of our digits back now. Let me zoom you in there. See that? Oh yeah, see, now we lost those. Yeah, okay. I think we can fix this one pretty easily, and that might give us an idea of how this works once we take it apart, and then we can look at the other one that is not working at all. Okay, time for some teardown. Okay, looks like we've got 2 screws here, and that's about it. So maybe we can lay the bail down. Okay, flat washer and lock washer. Go. Oh, it just pops off of there like so. Yeah, here you can see those fuses, how those just pop in there. Okay. And the front one is 250 volt, 1/8 amp. And the rear one is 1 amp. So you can set those in their respective positions in the cover. We've got another fuse right here, and if I can get zoomed in on that guy. Blurry, blurry. Okay, there we go. Maybe a little additional light from behind. Yeah. that has a resistor inside of a fuse. That's curious. So the resistor is gray, red, black. So what is that, 70 ohms? Yeah, I think so, 70 ohms. Huh. So make kind of a slow blow fuse, I guess. Try that part again. Okay, so we've got our AC entry here, transformer, little bridge rectifier. This looks like some sort of voltage regulator. Smart 613 and 3-394. Maybe an LM394. This looks like a Motorola marking there. Bulk capacitor. Gold-coated PCB. And this is our display. Nope, you can't see that. Gosh. I've redone my overhead camera mount, and I'm getting used to it about what is in view and what is not in view. Okay. There's a couple connections right here, which I'm guessing are for the battery, which would have set in here. The leads would have come out here. Yep. That's similar to other Fluke models, or HP models rather. And our display just plugs in there. Wiggle that out without disassembling the rest of the meter. The thing with measurement instruments is, on the really precise one, even your fingerprints can cause problems, so the less you have to touch stuff, the better. I'm just using this rag to cushion what I'm prying against. Don't want to leave dents in anything. There we go. Okay. Got our LED module out of there. That deserves a close-up. That is awesome. Here is that glorious bubble LED display. You can see we've got our digits in here and here and here on the ends. There's nothing. Now each, there's a bubble, circular bubble above each set of segments. And there's a convex cover over the whole thing too. This is kind of something that HP came up with for the original pocket calculators in order to make the current consumption of that era of LEDs low enough. They needed to make them really small. And of course then you couldn't see it, so they built in lenses to make it appear larger. So good engineering solution there. I see a little bit of some darkness right there. I'll look at that under magnification and see if that looks like corrosion. I'm guessing not. I'm thinking probably if we put some contact cleaner in here, brush a little on the pins themselves and slide that in and out of there a few times, that'll probably take care of our contact problem. So I'll do that and we'll get it plugged back in there and see if that fixes it. Okay, to try to avoid making a mess with the deoxit all over the circuit board, I have strategically placed some rags around here. And this is one of the new old style cans of deoxit without the stupid nozzle cap thing. So it doesn't drip like crazy and it's somewhat controllable. Red plastic guide there, not only to clean it, but to keep from getting deoxit sprayed on it. There we go. That worked out pretty well. Just in case, yeah, a little did leak through there, but it's not excessive. Okay, I'm going to spray some on a Q-tip, but not here, and we'll wipe down the leads on the display itself. Okay, now we need to clean our red shield there. Okay, for this I'm using some Brilliant Eyes. This works really good for this sort of thing, and it leaves kind of an anti-static type coating on there, so it won't attract as much dust and dirt. Slide him back in like that. Give the bubble itself a little wipe down. Okay. Oh, that plugged in a lot easier than it unplugged. When I put this back together the first time, I forgot to press record. So we want to put this cover in and make sure it's the right way up. I had that backwards the first time. Put our bottom cover on. Make sure that's all seated like it should be. And I will clean this cover up later on. Just want to make sure it works first. And if you have to do repair to the circuit board, then you've got to come up with a creative way of making your lead connection, since you won't have your integrated fuse holder thing here in there. Okay, I'm going to take one of my probes and push on that fuse to push it down. Then I'll push on that fuse to push it down. Keep trying to do that. And slide that cover over. There. Plastic spudger to the rescue. It's an interesting system, but not very convenient. Okay, now we'll move to the front again and see if we got our flaky LED situation resolved. Okay, moment of truth. Power on. Got our open circuit for ohms mode. Short our probe leads out. And look at that. We have all the segments, and we don't miss any when we shake it. Okay. We've got our 100K resistor. I think that's 100K. Measuring about 90K. That's a little off. This looks like 33K. 32.4. Okay, that's within 5%. And let me grab another one here. What is this? This also looks like 100K. 75K. Well, that's kind of odd. Definitely not in calibration, is it? Oh, I see what the line here is. It goes like this, so it's pointing to auto, and like that, it's pointing to hold. Okay, well, I'm not sure about the resistance measurement on there. We can put it in volts mode, and we should be able to measure 0. Why are we not measuring 0? That seems strange. There we go. Bad connection on the meter leads. Okay. These are not the best leads in the world. They're just what happened to grab, but they are Radio Shack leads. 278-704, and they say Micronada on the front. Alright, now I have my bench power supply running. You can probably hear the exhaust fan in the background there. It is outputting 5 volts. It's current limited to about 90 milliamps. So if we turn it on, we're measuring 5 volts. Alright, I'm happy with that. And I will turn it off again. We will put our plug back here in the ampere range. The probe's connected to the power supply again, and I'll put it in the amp range. Power supply on. And yeah, we're not putting any load on the power supply. Interesting. If I do this, definitely putting a load on the, I'm shorting out the leads, definitely a load on the power supply. So our amp range is not measuring anything, so we might need to test the fuse on this guy. And we'll do that. I'm going to go ahead and check the ohms reading again here real fast. Maybe that was just a case of my wonky probe connection. Kilo ohms. 86. Nope. It's reading kind of low. Yeah, these are definitely 5% resistors, so it should do a little better than that. This is 33K, so 10% would be 3K, 5%, 1.5K, and we're within 1.5K. So, well, let's check our current range fuse there and see if that's problematic. Okay, I don't even have to put that on the multimeter to test it. It is indeed blown. You can see it just right there. It's supposed to be an 1.5 amp slow blow. I'll have to see what the closest I have is. Okay, well, the closest I came up with was a 0.5 amp fuse. And it's supposed to be a 1.5 amp. And this one's actually supposed to be a 32 milliamp fuse, and it has a 1/8 amp, or 125 milliamps. And I tried to borrow the fuses out of the other one, and this one has a wire soldered on the outside of it. If you can see that there. Yeah. So that didn't quite work out. Alright, so now we'll go ahead and test the current on this again. Okay, once again I forgot to press record, so we'll go through it backwards in the way of testing. Put a 0.5 amp fuse in place of the 1.5 amp. I've got it set to AC in volts. Leads are plugged into the wall, 122 volts. That's correct. I installed a new set of leads. These are good leads. This insulator's a little chipped here and it's chipped here, but they're actually very nice leads. And if we put these on ohms, now I just measured these resistors a little while ago and got 100K. Oh. It shouldn't make a difference if I have the AC switch in, should it? Yeah, I don't understand the auto ranging on this. Or why this... That's very strange. There's something kind of wonky with the... Put it down on the mat here. Oh, I guess it's just measuring a little current flow through me. That's interesting. 99K. Alright. Problem was operator error. It was measuring the leakage current through me. I must have a low resistance this morning. 100K. Okay, the meter's fine. The operator's faulty. Now, let's plug the positive lead. Oh, these are tight leads, man. Amps. Amps. Amps DC. We will hook up to the power supply. And power supply showing 92 milliamps. We've got 92.9 milliamps here. Given the accuracy of the power supply, this is probably more accurate. We're probably closer to 93 milliamps. So that's awesome. We have a fully working HP 3476A. I've got the cover off the second meter that wasn't reading much at all, so we'll go ahead and have a quick look at that too. I spent quite a bit of time studying the schematics and service manual for this HP meter. This is a good one that was working. I've got a part here. This is the one that is not working over here. The manual describes various test points here for checking power supply voltages. There's a +6, a -4. There's a 1 volt reference for the current source for the ohms function. Internally, this rectangle represents this is internal to this hybrid IC. There's a voltage divider which provides a plus and minus 159 millivolt reference. All the voltages are fine, and I could put it to ohm scale and see that the 1 volt reference was going out and back in and into pin 24 on the hybrid IC, but still the display on this bad one was not updating. So then I got to looking, it's like just like a computer. It's like, okay, what is the basic things that you look for? PCR, power clock, and reset. So I said, okay, this thing's got to have a clock. It's driving a display. It's got to have a clock that the internal logic in the hybrid IC is working off of. So I looked at the manual and I found out, yes, right here at pin D, I'm pointing to it with my thumb, is the clock output. I'll pop a picture up here on the screen of the good output from this unit. There is what looks like an RC circuit external to the chip that creates the clock. It's just right here. So pins 1, 2, and 3. I can pop up those signals here captured from the good one. And on the bad unit, we have a very, very low amplitude signal. Only, maybe 200 millivolts, not, 3 or 4 volts like on the good system. So, that got me wondering, well, there's not many parts in this circuit right here. There's not much to go wrong. The potentiometer seems to be okay. I can't really test this cap in circuit. At the measuring this fixed resistor, which is supposed to be 88.7K, and noticed that on the good unit, measure one polarity, we get about 89K, the other polarity 81K, so pretty close. There's a little difference there. And on the bad unit, 85K one direction and I cannot block the meter. 21K the other direction. So something's drastically different on this meter. And if we measure from the test point, the reference test point, all the voltages here on the power supply, you don't go from, there's not like a simple ground like there is on a Commodore 64 or something like that. Piece of test equipment, the voltage rails are completely different, kind of wacky looking if you're not used to it. There's always a reference test point that you find that you measure everything to. That is over here. So if we measure from that, 2 pins 1, 2, and 3, which is where that clock generation is. I've got the negative on the common test point. So we have open, 1 meg, 1 meg, and on the bad unit, I don't know what that is, that flashy flash, if you can see that. 400K, 400K. If we go the opposite polarity, pin 1, 100K, 1 meg, close to 1 meg, and on the bad unit, 18K, 100K, 77K. So there's some sort of leakage in this unit, which I'm guessing is in the hybrid. We can go ahead and pull this circuit board out and see if there's anything underneath it that's causing a problem. Maybe pull one lead up on the resistor here and capacitor, but I really don't think those are causing the problem. That would be worth doing, especially on the capacitor in case it's acting wacky. But I think we have a bad hybrid IC on this. So we'll go ahead and we'll pull the circuit board out just to have a look. Okay. It looks like there is a screw here, here, and probably on this bar that's holding these switches. At least this one, I can see it goes into a post. And it looks like these ones up front here are a little bit different than the ones in the back. A little smaller. Okay. Oh yeah, these are shorter and fatter, and the front ones are longer and skinnier. Okay. Take those 2 spacers off. Red toward the front. And maybe this spacer needs to come loose. Nope. Yeah, there you go. You got to hold your mouth just right. So this just has a little RF shield in the bottom that wreaks havoc with the auto exposure. Here's our pins 1, 2, and 3. Yeah, there's nothing really amiss looking there. Now it says in the service manual to wear cotton gloves when handling the circuit board. I'll zoom in here. You can see these little white Teflon things where they have certain junctions done. That's done to create a really high impedance path on certain junctions, so there's no leakage even through the circuit board. And so, you touching the board with your bare hands can leave oil and cause problems. Yeah, so that's the resistor connection. That is the capacitor connection. Okay, I'm going to try lifting one leg of that capacitor out of there, and we'll measure it again and see what happens. So I pulled up one leg of the resistor that's in that clock generation circuit and the capacitor, and it's supposed to be a 390 picofarad capacitor, and it's right on the money. Sometimes it tests at 391, but it's fine. The resistor's fine. Oops, gosh. We definitely have a problem with our hybrid chip here, which means that this unit is not repairable, unfortunately. So I'm going to go ahead and solder these parts back down and reassemble both of them, but at least we got one working chip out of this. I'll see if I can zoom in and show you some of the crazy construction on this guy. You see there are legs on components like the chip here bent out and into these little solder pots. This is like a piece of Teflon inserted into the PCB with component leads poked into it and filled with solder. So this creates a better insulator for this joint, and it eliminates any leakage through the PCB. There are guard traces like this around things. Like this junction right here has a guard trace around it. Let's see how this IC has legs bent out and soldered into those little solder pot things. Absolutely crazy construction. Rather interesting. There was an article about the construction of this, low-cost digital multimeter in the HP journal. I'll put a link to it below. That was kind of interesting. Just all the innovations they did to come up, with this IC and the construction in general to lower the cost of a auto-ranging digital multimeter with, good accuracy in 1977. So anyhow, I'll get this popped back together, and then we'll make sure that our good meter still works. Well, I guess we did okay. We got one out of the two HP 3476A meters working. This one seems to be fully working. It cleaned up well. I did not calibrate it. I don't think I'm going to use this on a day-to-day basis. It's just a neat artifact. Had some bad luck with this. It wound up with a bad hybrid IC. There's nothing we can do to fix that, but sure learned a lot. Had a lot of fun working on these two. I noticed on the LED display, if you move kind of in front of it, it changes how it looks a little bit. There's a little bit of an asymmetric type of effect going on. That's just an effect of the lenses they use to make those small LED segments visible. But it's a good example of the ingenuity of HP at this time, really pulling out all the stops to make a low-cost digital multimeter in 1977. I don't often do test equipment repair videos. If you like this type of thing every once in a while, let me know. I still have some more old meters on the shelf we can take a look at. Other questions or comments, well, just pop them in that comment section down there below. I would love to hear from you. And until next time, bye.